Hey, what's up guys? Thank you very much for being an electric. I really appreciate that. Now, what I have here is called automatic changeover phase selector. Automatic changeover phase selector. Now you have to remember that we did a couple of videos about automatic changeover switch, and then we did other videos about phase selector. All right? And automatic changeover switch has got its downsides, okay? One of them being generator to run when you're missing a phase, because it's a free phase changeover switch, okay? Again, when you look at the other hand of a phase selector, which is quite good, which selects between among phases, but the problem is that you don't have a backup there. It's independent on the grid, okay? So meaning you need to do another circuit for the backup. But now this integrates the two, okay? The two devices in one. So the changeover switch and the phase selector. And the changeover switch, it has the main contactor and a generator. The phase selector will have only the three contactors for the red phase, yellow phase, blue phase. But now it is incorporated in one, which makes it unique in many ways, okay? First, in your installation, if you have this kind of device and you have a three-phase system, then it means that this contactor will be running for that matter, and all the three-phase devices will be running and your entire installation. But in any case, if one phase misses, then one of these three contactors will choose. The system will choose which one is best. For instance, the red phase is out, you're remaining with yellow and blue. So the system will choose between yellow and blue which one is better or more healthier, and then it will engage. Okay? If the grid is totally down, unavailable, then your generator will come in and it will serve. Okay? So, there is no problem to use a single phase, okay? Because literally one phase will miss in your three-phase changeover switch and you will not have power. Your generator will run, you're going to burn fuel, okay? But why you just need to have a phase selector switch like this, whereby if three phase is missing, the red phase will come in and maybe your computers and all other single phase gadgets will be supplied. And then even the dark hallway will be illuminated. All right? Okay, so having said that, let us explain a few things here. Now, you're seeing right, we have 5 contactors here. This is a three-phase contactor, which now will be carrying the red, yellow, blue phases. Okay? This is the red contactor, yellow contactor, blue contactor, and the generator. And then right here, we have got some breakers here. So here we are using single pole breakers, okay? Because we don't want, if there is any problem with the circuit and it trips, we don't want the entire circuit to trip, okay? Because it's a three-phase automatic changeover phase selector. So we will have a single pole, okay? So that if a breaker trip individually, all right? Secondly, then the side of the generator we have linked, because the generator gave us smooth and, regulated voltage, so we can have a linked, okay? All right, then we have the output breaker right here. We have not linked. You can link this one if you want, but we have not linked, okay? So it's 1-1 breaker, all right? So that's the power circuit for you. Then when you're wiring the power lines, okay? So because we have a three-phase in the system, all right? And we have 3 breakers here, which you have your red phase, yellow phase, and blue phase. The first contactor will take all of them, the way you see, all of them. And then The second contactor will take only red and will loop it around, because I said, because you have an installation, which is the installation is a 3-phase. So which means that the circuits in that installation are balanced on each phase. All right. That's why we need to loop around such that when one phase is running, the entire installation will get power. Okay, much as the 3-phase devices will not work, but the rest of the installation will get power. Okay, so when we come to yellow phase, we've looped around. Blue phase, the same thing. Okay, when we come to generator, the generator is independent because you run your wires from the generator and then you enter them in this contactor here. Now, this side will have to loop everything around. Okay, we have to loop everything around, and then we get our 3 wires, which is red, yellow, blue, to the load contactor. I mean, to the load breaker. All right. I hope there we are at par. All right. Now, let us talk about the control devices here. Okay. So there are quite a number of them, and I will explain each one of them. Okay. The video is long. If you want, you can skip around. All right. Now, first here, what you see here in the control circuit. Now, first of all, this control circuit is divided into 5 parts. Okay, as in respect of these contactors. All right. So the first part is the mains contactor. Now, the mains contactor is here. This is the control. Now, in the mains contactor control, we have 3 fuses. We are using fuses, not breakers this time. Then we have 3 comparators. Okay, voltage comparators. We have 2 relays here, and then a timer, an on relay timer. Okay, all right. Now we go to the red phase. Red phase is this one here. We have a fuse here. It could be a breaker. Then we have a phase comparator. We have a timer and 2 relay. We go to yellow phase right here. We have a fuse, phase comparator, timer, and 2 relay. We go to blue phase. We have a fuse, we have a phase comparator, we have a timer, and 2 relay. Now we go to the last part, which is the generator, where we have a fuse, control fuse, we have a relay, and then we have a timer. Okay. Now, you may ask, hey, David, why do you have a lot of components there? Can't you use a few? Okay, I'll explain a little bit. Now, right here, these are 3 comparators because I have a 3-phase contactor. Now, you realize that in my lab, I don't have a 3-phase power supply. Now, in my lab, I don't have a 3-phase power supply. If I did, I would have used this GIC power comparator, voltage comparator, which has got the 3 input phases, all right here under neutral, and then would control a circuit. But because I don't have a 3-phase in my lab, so I will have these single-phase voltage comparators, which will control this contactor. However, if in any case you're designing or wiring this kind of circuit and you don't have a 3-phase comparator like this, you can use this single phase and they can work perfectly fine, as you will see in this video. Okay, now let me talk about the relays. Why do I have so many relays in my circuit? Okay, and this is the reason. First of all, why do I need a relay in the first place in this circuit? All right, I need the relay because if we look at the rating, and this is a habit you have to adopt, if I don't want to, because this is the last bit, the last component in the line of the mains 3-phase contactor. So that means that this guy here is supposed to supply the number 18 of this timer here, supposed to supply this contactor. Okay, but in some cases, this contactor tend to the coil to be rated high. Okay, so I would prefer to have this timer supply the relay, and then the relay will supply the contactor. But again, also, having said that, because we want to use the interlocking mechanism in this circuit, this is a 5-contactor circuit, so you don't have to mess around. And by the way, disclaimer, this circuit is quite sensitive, so you really need to be knowing what you're doing, because you'll be dealing with different phases. So ensure you don't do any short circuit in the circuit here, okay? It can be messy, all right? Okay, back to the video. Now, I have 2 relays here. I want to show you now if I have 2 relays here. So I want to show you all these contactors, all these circuits. So this is the generator, yellow, blue, and red. They have to go through the mains or the 3-phase control circuit, okay? Because we want to make this contactor the priority, all right? In that, when all the 3 phases are available, this contactor here will engage, okay? As long as we have 3 phases here available, this contactor, this one here, will engage. Now, if there is no one of these is missing, then definitely we will have this one of these contactor to engage. If red is missing, we'll have either blue or yellow engaging. But in case this comes back, then we want the moment all the 3 phases are available, this system to override the rest. Okay? So same thing. We are making mains the priority to generator. So if the generator is running and then the yellow phase is okay, then the yellow phase will take over the generator. The blue phase will do the same, and the red phase will do the same. But the mains or the 3-phase contactor will override everything, whether red, blue, yellow, or generator. As long as these parameters are in good reaches, definitely everything will be override. That's why each contactor here have to go through the mains relay. That's why I need to have, because if you look at this base here, it has got 4 contacts, okay? So this is 1, 2, 3, 4, okay? So meaning that this contactor, this relay base will carry the 3 phases and the generator, but it's also supposed to carry self or itself. So that's why I add this one here. And also another thing, if you have this some kind of indication, it can also go through the same. All right. All right. Now, the same thing, you see, I have 2 relay. So each one of these generator, this, the blue, yellow, they will have to go through red. Okay. The same thing. It's only the generator that doesn't take any interlock for any of these. All right. Okay. Then we come back to the auxiliary contact. Okay. Now, auxiliary contact is protection. So we give a double protection here. We give protection in the relays. We also give protection on these interlocks. Okay. Now, these are 4 interlocks on each contactor. So that means that each contactor goes through the interlocks 4 times. Okay. So if we are wiring the 3-phase contactor, it will go through 1, 2, 3, 4 before it gets energized. Okay. So that we can have a very smooth operation of the circuit. Okay. All right. Now, I think I've talked about, everything. So let us wire this circuit. Now, the one thing you have to understand, I'm not going to wire this circuit with you here because that will take forever. It takes really a lot of time to do that. Okay, so but you'll have the circuit, okay, and then you've already understood. And another thing which I'm going to do, I'm going to use different wires on each circuit. So the three-phase contactor will use a different color. The red phase, yellow phase, each and every component will use different color, such that you're able to see which contactor, which part pass where. I think that will be something great. Okay, so let's wire this in 1, in 2, in 3. All right, this is our circuit right here. So we need to experiment a few things right here. Okay, so as you remember telling you, you have got the comparators here, three-phase comparator, and then you have the fuses. These three fuses controls the three comparators here, and these comparators are controlling the three-phase contactor right here. Then we have got a timer right here and two relay that everything here controls this contactor, which is the three-phase contactor. Then we have got this part here, which controls the red contactor. This part controls yellow contactor. This part then controls the blue contactor. And then the last part controls the generator, right? So let us see a little bit. I just want to remove this relay. All right. So you remember when we were beginning the video, when I talked to you about why I have a number of relay here. Okay. So if you look at these bases, you realize that each and every contact on the two bases has been utilized. All right. So let us look at this relay here for the red phase. If you look at the relay here, you will see that you're able to see the red phase and the blue phase passing through the red relay. If you come to this area here where we have many yellow wires, which is the yellow relay, you notice that we have blue and red phase passing through here. If we come to the blue phase where you're seeing many blue wires, you realize that we have yellow. We have yellow coming out here, and then we have red. All right. And because I've used orange for generator, you realize that orange is everywhere. You see, from the main relay, you see this is orange through red, orange through yellow, orange through blue. Okay. All right. Now, what you have to know about this circuit, and remember, the circuit is called automatic changeover selector switch. Okay, automatic changeover selector switch. And we've just taken the selector switch of 3 contactors, and then we added automatic changeover switch of 2 contactors. Okay, so when you hit a power supply, 3-phase, all the 3 phases are available, this will be on. Okay, and then we've done, we've prioritized this contactor here, the 3-phase. So if all the 3 phases are available, this contactor will engage. Okay. So this guy here, as long as 3 phases are available, overrides all these. But also each phase overrides the generator. Okay. So the generator is the last thing to run if only there is no single phase that is online. Okay. So that's why I've used, different colors such that you're able to see and to see how things works. Okay. All right. So the 3-phase contactor has got 3-phase fuses here with these comparators, a timer and 2 relay. Okay. And to make this contactor or this three-phase contactor priority, meaning all these guys here, they have to pass through the main or the three-phase relay. All right. Now, when you come to individual phases, you excuse me, you can see that we have a fuse, we have a comparator, and we have a timer. Okay, and we have interlocked each and everything. Let us look at the generator signal. Now, you know most generators use the closed signals. Okay, generator uses closed signal. That on each generator has different ports. They are always manuals where your remote start signal is. So that remote start is always closed. So if it is closed, then the generator starts. If it's open, then the generator stops. So that means that if these contacts are on, they keep. So I have these two contacts here. You see them right here. This is remote start. This circuit here is ready to go. It can do the job perfectly well. So you have remote start here. Where do I get the remote start in the circuit? Okay. So the remote start in the circuit, you have to create a way, because it's a closed signal, meaning that as long as these contactors, there is power, this contactor will be engaged, right? So meaning the normally closed contact will now be open. Okay? Will now be open. So once they are open, generator will not run, will not get a signal. If power goes and this contact closes, then generator will start. But we have to do it through all the contactors. So you can choose to do it either in the relays, or you can choose to do it in the auxiliary contact. The power is yours, okay? But you have to make sure that the signal has gone through. You just connect it through, just a series connection from the mains, from the three-phase contactor to the yellow, to the to blue, and to red, such that if any of the grid contactor is engaged, there will be no signal for generator. So let us put these relays and we see. Okay. All right, let us put the last relay. So everything looks great. Now, let us first see if all the contactors engages. So we'll start with the red contactor. So the red contact engages. Switch off. Let us see the yellow contactor. Engages. Let's see the blue contactor. Engages. Let's see the green contactor. Engages. Now let's see the three-phase contactor. Engages. Okay? So let us see how this thing operates in real life. Okay? Now, the beginning, let us see. Okay, you have a red phase, which is on, supplying the circuit right here. Then, for some reason, we have now the yellow phase is healthy. So you see, when the yellow phase comes back on, nothing happens because already red is online. Now, if the blue comes back, let's see what happens. Blue. Now, you realize that the moment blue is back, because this guy already detected that the voltages are fine Now, the system has switched from now red to 3-phase. Okay, so you realize that we have the 3 phases available. So the blue phase is indicating, the yellow phase is indicating, and the red phase is indicating. Okay, so if you also look here, you can see the voltage parameters of the 3-phase on the 3-phase comparator. So that's why our 3-phase contactor has engaged. For some reason, if the yellow phase has got under voltage or it's off completely, this is what happens. So the yellow phase got a problem, and then this de-energizes the 3-phase contactor because it's no longer viable, and then the blue has come in. So the system will choose between blue and red. Okay? So the blue has come in and is now supplying. So assuming right now, if blue disappear, what happens is, okay? So if blue disappear and red is okay, red will take over. All right? And once all the 3 phases are present, you look at that, the 3-phase contact will take over. Now, let us test the generator. So, if you take this thing to test with it, the generator, this is what happened. You know very well that if this power shades like this, so we don't have power anymore, this signal here, because it has been open, so now it becomes closed and the generator will start. Once the generator starts, generator relay on. Generator relay on, timer comes on, this relay goes on, and the gen contactor engages. And now everything will be running on the gen contactor. So if good something happen, and then maybe the yellow phase comes, will override this. Let's see. You see that? So because the yellow phase has come, you override this. Now what you do with the generator, you put some delay. Okay, so right now, meaning that the generator is on cooldown. Okay, so I need to use this meter here, and I want to show you something. Okay, I want to show you something. I don't know whether you will see that. Okay, yeah, that's better. So I've put this meter in the, let me put in the continuity. So this is the signal which is supposed to be closed. If it is closed, generator runs. If it is open, generator stops. So if there is no grid completely, this shorts. So it sends a signal to the generator. Generator will start. Okay, so that as long as it is closed, generator will keep on running. So if power comes back in one phase, let's see. You see, the buzzer has gone off, so the generator will receive a cool down signal. Okay, because now the contacts are open, the generator controller will pick that up and say, okay, and then it starts cooling down the generator. So usually what happens is you can extend the cool down time, okay, a little bit, such that in case this power is fluctuating, this contactor, the gen will be still running, so there will be still power here, so the contactor will just enter. All right, so this is it now. You see, when the gen is running, our 3-phase comes back, this contactor comes in. Okay, all right, so you realize that as long as all these comparators are showing, definitely the 3-phase contactor will come in. So how good is that? All right, so I hope this video helps you in your project. All right, and by the way, this circuit here, it really helps a lot. It can work pretty well, maybe in your home, in the hospital, in the mall. It can work pretty well. Okay. So this has been just a combination of, selector switch and changeover switch. So thank you very much for watching. Please don't forget to subscribe, to like, and to share. Until next time, I'm out.